What I am going to talk about is delivering geothermal heat, which does deliver impact for decarbonisation projects, but in a very specific sense. I've thrown in the partnership, actually really to recognise Andrew invited me to give this presentation because we are working very closely with Veolia and in fact a number of other suppliers, because what we've learned over the last 2 or 3 years of delivering geothermal projects is that bringing heat to surface is only part of the story. In order to make it work efficiently, effectively and ultimately commercially, you need to have a partnership between the subsurface, that's what we do, and the surface engineering, obviously, which Veolia and others can deliver. So, who are we? I work for a company called Star Energy. We've presented here before, but not under the banner of Star Energy. We were previously known as GT Energy. We renamed the company. Those of you probably familiar with a little bit with GT, it stood for geothermal heat. So we deliver geothermal heat. Star itself as a company has got a much longer term heritage. We've been operating as an oil and gas company for 40 or 50 years onshore UK, focused solely in the UK with our oil and gas business. But as a consequence of that, we know the geology of the United Kingdom incredibly well. There's a nice picture of all the different bedrock that you have at different locations around the place. Over the last 4 or 5 years, Star has been transitioning away from hydrocarbons and moving into the delivery of geothermal heat. Uses very, very similar skill sets. Ultimately, we're looking for hot water, a fluid buried in rocks, 1 kilometre, 2 kilometres, 4, 5 kilometres beneath the Earth's surface. Very similar skill sets. We employ the same geologists, geophysicists, well engineers, technicians who can then operate and maintain those facilities over the long term. Our mantra is to bring to geothermal projects what we used to do as oil and gas operators. As an oil and gas operator, no one pays you to go and find the oil, go and find the gas. That's on your bag, and then you make the money on the back end of those projects. So that's what we do as a geothermal operator. We will take all of the development risk, we will take the geological risk, we will take the drilling risk on our backs with a contract to sell heat over a long-term basis at the end of that project. But all of the delivery risk is on our backs. For those of you that have attended these presentations over previous years, you'll be familiar with the concept, and I know a lot of people now are starting to be familiar with what we mean by geothermal heat. But for those of you who've been living in a bit of vacuum and for who it's new, one quick slide really just to summarise what do we mean by deep geothermal energy. Fundamentally, the name means heat from below the Earth's surface. Deep geothermal typically means anything from 500 metres down to 5 or indeed even deeper, 5,000 metres or even deeper than that. What you're looking to do though is not just find hot rock. Every school kid knows the deeper you go into the Earth's surface, the closer you get to the core, the hotter it gets. What we're trying to do is liberate that energy and bring it to the surface. And the way we do that is by using a liquid. Across most of the United Kingdom, there are layers of rock which already contain liquid. So when that's close to the surface, we call that an aquifer. And a lot of people, they drink water. Where I live in the south of England, we drink water that comes directly out of a chalk aquifer that runs across the area. We're doing exactly the same thing, apart from we're drilling to 100 times deep. So rather than 25 metres, it's 2.5 kilometres. But fundamentally, it's exactly the same technology. We're finding a resource that's mobile, that's liquid. We can bring it to the surface. We take the heat out, and we'll talk about that more later on. We take the heat out, and then we return the water to whence it came. And that's really, really important for 2 reasons. One, unlike those potable water aquifers at 25 metres below the surface, it's not really water. It's water with an awful lot of dissolved minerals in it. Salts, carbonates, chlorides, all kinds of nasty things. So the EA are really, really keen that doesn't leak into surface water or indeed into those aquifers. So one of the key challenges we've got is demonstrating to the EA that we've got a safe way of operating the wells. That's what we do as an oil and gas operator. That's what we do as a geothermal company. So we put it back down to where it came from. EA's happy. But also, by putting it back to where it come from, we don't deplete the reservoir. So if you continue sucking all the water out and you're not replenishing it, of course the pressure's going to drop. There's no energy in the system. It gets harder and harder to pull the water out. So actually, by returning it back into the system, we keep the energy there, and we're able to continue operating the field for much longer. The oldest, geothermal heat has been around forever. Most of you, I'm sure, have probably been to the city of Bath. Bath runs on geothermal heat. Been there since the Roman times, even before that. Purpose-built geothermal in the way that I'm going to be describing later on. That's been around for about 130 years. The first wells were drilled in 1892 in the US. They're still producing today. And that goes to show you sort of the longevity of these projects. If they're designed properly and operated properly, they will continue to keep giving heat on a long-term basis. And that's why it's so important to return the water back there, because otherwise it runs out. It's proven. I've just talked about plants in the US that have been running for 130 years. More recently than that, cities like Paris. Paris went through a massive boom in the 1980s, building loads of these projects, and they've continued that. They now have more than 60 operational geothermal plants at various locations, from the centre up to the north city. If you've been to Euro Disney, that's heated by geothermal heat. If you've flown into and out of Orly Airport, that's heated with geothermal heat. It's very, very popular technology in Paris. City of Munich, they've been working in the geothermal space probably for the last 15, 20 years. They've now got 30 plus operational plants, and they've made it Stadtwerk München, who are the sort of the city equivalent of GMAC. They've made a commitment to have totally decarbonised heat supply by the 2035. The vast bulk of that is going to be through geothermal heat, dotted not just through the city centre, but actually in the periphery around the city, and then piped in to support a heat network. Incidentally, we're here in the city of Manchester. Manchester, from a geological standpoint, is very, very similar to Munich. So there's nothing preventing us from doing exactly the same thing here. The image in the middle there, that's a drilling rig. In order to drill down to 2 kilometres, 3 kilometres, 4 kilometres, that's what you need to have. Fairly large piece of kit, and there's no getting away from it. It occupies 4,000, 5,000 square metres. But it's only there for a very short period of time. As you can see there, that's in a really, really urban environment. I mean, that's Paris, but you can imagine that sort of thing in a location here in Manchester quite easily. Once it's been decommissioned, once you've drilled the wells, you take the rig away and it goes off and drills another set of wells down the road or in another country. What you're left with is a little enclosure like that. So that's the surface footprint that you're left with and is there for the 100 years that you're operational. Now, in the case of that, it's got a removable lid, because we do occasionally need to get back into the wells. Sitting in a production well is a pump, and that's a replaceable unit. They fail typically on about 8 to 10 year cycle. So what we do is we lift off the lid, we take off the wellhead, we drop a wire line, which is basically just a winch, down into the well, we hook up the pump, we put down another one, hey presto, we're good for another 8 to 10 years. The important thing, and we'll keep on coming to that through the rest of this presentation, is these are large scale systems. They're designed to lift water through that pump to the surface, and we're talking mega quantities of heat, tens of 50, even up to 100 gigawatt hours per annum out of a single system. All zero. So in order to do that, we operate the pump, as I was saying earlier on. So depending on how you operate that pump, or rather what you put into the pump to run it, that can be completely zero emissions. If you're using green electricity, it will operate completely without any emissions or entailed emissions associated with it. Unlike a heat pump, so conceptually you can think of this as basically just like a heat pump on steroids. Why do I say on steroids? Well, those volumes of heat imply very, very efficient systems. Heat pumps, COP of 2, 3, if you're talking about a water sort heat pump, 4 or 5, maybe, depending on whether or not you believe the manufacturers. COP for a geothermal plant, because it's lifting energy that's usable, directly usable heat, because it's lifting that in its native form, COPs of 15, 20, 25. So incredibly efficient. That means when it comes to actually installing one of those in your facility, you don't have you're much likely to have the sort of grid constraint problems that an air source heat pump or a ground source heat pump project might entail. I've sort of touched on a lot of this slide as we were going through, but there's a couple of things I want to highlight, particularly associated with the image there on the left-hand side. Geothermal comes in multiple flavors. What I was describing to you a moment ago by talking about the production well and the injection well is a form of what we call hydrothermal. It's lifting water to the surface. Open loop because it's not open at the surface. That's where you've got your heat exchanger. It's open loop at the bottom, where we pull the water out of the hot water out of the rock, and we're returning the cold water back to where it came from. So that's a hydrothermal, open loop technology. Over on the left-hand side there, we've got shallower schemes. Now, those you might come across. A ground source heat ray is one example of a closed loop shallow scheme. You can carry out that same technology to a number of different depths. And I know that people out there, we're looking at opportunities down to sort of 1,500 meters. Obviously, the temperatures are higher with closed loop, but because you don't have liquid flowing into the system, they don't generally have the same volumes of heat associated with them. But they can be quicker to deploy. Over on the right-hand side there, what we're trying to show is sort of larger scale systems which are going even deeper than the 3 or 4 kilometers that I was talking about earlier on. Now, in those scenarios, they're actually going right down into sort of what we call basement rock. This is super hot granites, basalt type things, and there you can be looking at 150, 160, even at 200 degrees. Star, as a company, in our geothermal arm, we've actually got a number of overseas ventures. We're working in Croatia. Croatia's got a different geological system because it's right next to the Alps, so the temperature gradients are much higher. We're drilling some projects there which are drilling down to 200 degrees, 220 degrees. So as a consequence of that higher temperature, you're not just able to use it for heat, but you can use it for electricity as well. So by running it through a device called an organic Rankine cycle engine. So this is basically like a turbine, a steam turbine, but rather than using water and turning that into steam, it uses an organic solvent. And so by heating that, we can generate electricity at lower temperatures. They will operate from 70 degrees. Typically, in order to get anything like a reasonable efficiency out of them, you do need about 150 or 160. But going down deep into these granitic systems, you can liberate those sort of temperatures and generate electricity. And there are a number of locations in the UK where that is being done right now. The project down in Cornwall, United Downs, they're actually in the process of commissioning their ORC, the Rankine cycle device I was talking about a minute ago. We don't have that everywhere. We don't have those sorts of temperatures available to us everywhere. But what we do have is usable heat. And on the right-hand side there, we're showing some examples of the temperatures and the uses to which that can be put. We ourselves here in the UK are working on a couple of projects for hospitals. One at Salisbury and one at Wythenshawe. The one in Salisbury, that's prognosing temperatures in the mid-60s, between 65 and 70 degrees, and that's as a consequence of where the rock that we're looking to produce from lies. In the case of Wythenshawe, that sits in a much deeper basin, so we're going to be drilling down to around about 4,000 metres there, and the temperatures are consequently going to be much higher, between 110 and 115. Having those sorts of volumes of heat, fantastic. It means you've got more energy to go around, and that gives you potential for larger scale systems and basically more consumers of the heat that might be interested in gaining access to that one resource. My closing thought, really, as we move on to the next slide, is the fundamental principles of deep geothermal energy then are about finding the right rock at the right depth. That project at Wythenshawe that I just talked about, 4,000 metres, that's fantastic. We've got a great big volume of heat to do that. But in order to access it, you've got to sink in an awful lot of capital. CapEx costs for a rig that's big enough to drill that, and it's going to be on site for a long time whilst you're drilling that. That comes to a large commercial investment. In order to make that investment, ourselves as a developer, or indeed anyone else, they're going to want to get a return on that. There's obviously financing involved. That means that the cumulative costs in the project can build up. And this is where we start to get into the concept of partnership. So me bringing the heat to the surface, great, I've got loads of it. It's 110, 115 degrees, fantastic. But if I can't sell it because it's too expensive, well, the project isn't going to go ahead. I can't raise the financing. I can't get people interested in joining the scheme. So this is where, as I said earlier on, the idea of having partners involved in the project, you can then extend the reach of that. So rather than making it just one developer, ourselves selling heat to a hospital, but building a network, quite literally a figurative network on the surface, to connect up multiple people, so you can spread that capital cost rather than just being across one entity, one customer. You're now starting to sell it to 2 or 3 or 4, perhaps into a district heating scheme in the right location. And that enables that project to go ahead and deliver decarbonised heat across a wider area, not just to 1 or 2 particular customers. On the right-hand side, we're talking about just really reinforcing some of the points that I mentioned earlier on. That long operational life, that leads towards long-term supply contracts. Well, that's helpful because that means I can spread those capital costs not just over 1 or 2 years, but actually over a 15-year cycle. Some of our customers were actually looking across 40 years in terms of the commercial agreement to, again, as a way of lowering that commercial barrier. Very high COP leads to a low OPEX. And that informs really some of the fundamentals of the commercial model that lies behind the geothermal part. High CapEx, absolutely. Can't get away from that, but very, very low OPEX. So by building a partnership around a project, we can actually leverage that low operating cost, which means we can deliver more heat for very little incremental cost. And that way we can slice up the CapEx and make the project more affordable for everyone. So we've moved away from a world where it's limited by that high capital one to to one where if we're operating the well, if we're building the project in the right way, we can actually make it extendable and work for more people in a given area. That commerciality question is sort of solved by putting together consortia, building a partnership that supplies more heat, does it in a way that enables those customers to come on board sooner because we've got a scalable solution that enables them to be connected together. We can do it more efficiently because that low COP that's inherent within deep geothermal that isn't available to others, and we can do it more of the time because of the uptime of a geothermal plant is much greater than other commensurate technologies. So this isn't just vaporware. I've mentioned a couple of projects that we're involved in Salisbury and Wythenshawe. We're working elsewhere as well. And what I'm going to focus on the last 2 slides really just give you a snapshot of how these projects are coming to life and what they're doing. Okay, so this is the city of Southampton. Now, Southampton is known as the first geothermal city in the UK. It was a geothermal well was drilled there in the 1980s. It was an exploration well, a single well, and it's been operating intermittently since then. Why do I say intermittently? Well, as a result of it being only one well, they're not able to return the water to where it came from. So it's been depleting the reservoir. As a consequence of the geology, it does occasionally top up. It gets the rock comes up to the surface, which enables water to trickle in. And when it builds up to a certain level, they can operate it for a bit longer, and the cycle continues. We're working with Bring Energy, who are the operator of that well and of the heat network that was built around it from the 1980s when that well was first drilled. So the bit in the bottom there.
Good afternoon. Healthcare Estates will be closing in 15 minutes. All delegates, visitors, speakers and exhibitors are invited to join us in the junction for the closing keynote, where we will discuss prevention is better than cure and refreshments will be served until 5 o'clock. Thank you for coming to Healthcare Estates 2025 and we look forward to seeing you again soon.
I'm on the clock now. Right. So the yellow bit at the bottom, that's an existing network. So we're contracted with an agreement with Bring to look at how we might decarbonise it by replacing their now aged and failing geothermal well, because it was only drilled as a single unit, with two more wells that would be drilled to a deeper depth, will enable us to lift more energy, decarbonise the whole of the network because it's currently running on a CHP, and running up to the north of the city. So there's a new geothermal, district heating network, which will be heated by our geothermal wells, running right the way to the top of the screen there. For those of you who know Southampton and have got an idea of it, that's the university. So we're also including in this scheme the University of Southampton. It's got a demand about 2/3 of what the existing network is. So by building that partnership between Bring, ourselves, the University of Southampton, we've got a scheme which enables us to operate commercially, and in fact we're predicting prices which are below the cost of gas for this scheme, and obviously have all the benefits of decarbonised heat and that long life of operation. For those of you who were around yesterday morning, you might recognise the picture, at least, of the hospital. So this is a project we're working on with Veolia. It's currently got some PSDS funding. We're in the process of bidding it. We're hoping to hear very shortly. This is a scheme at Countess of Chester Hospital. So the partnership that we're working on there has actually explored that commerciality equation in a different way. So rather than necessarily looking to go as deep as possible to lift up the highest temperatures as possible, we've proposed two different schemes that, by working in that partnership mode, will offer different benefits depending on the route that the trust want to take. So what do I mean by that? Well, we've actually got two potential schemes. There's a shallow scheme, prognosed around an 800-ish deep well. So that's producing temperatures actually relatively quite low. We're looking about 35 to 40 degrees C. Bringing that to the surface, boosting it with a heat pump. Now, as a consequence of that relatively small scale, because it's drilled shallow, it doesn't have a lot of energy within there, it's perfectly sized just for a hospital. So if we're looking, talking to the hospital, that's a sort of scheme that will work quite happily for them, gives all the benefits of a decarbonised scheme, but at the cost of a little bit higher OPEX, because you're having to run that heat pump. But it works, and as Andy Yates presented yesterday morning, it gives a scheme which is NPV positive. Another scheme, if we want to think bigger and expand that partnership out into the wider environment around the hospital, would involve going deeper. Go deeper, higher temperatures, more energy to go around. Okay, more capex, but we've already explored the ideas of how that might be solved. By having higher heat volumes, we can then actually bring other parties in there. So we're looking at the opportunities presented by a heat network, which might connect up 2 or 3 different users in the immediate area. Fortunately, some of them are existing Veolia customers, which gives us an opportunity to bring them into the partnership relatively easily and build that project towards a different commercial solution, but again, which brings the opportunities that decarbonised heat will bring to all of those different partners. So, early days. Geothermal heat is really at the beginnings in this country, but as I was talking about earlier on, we are some way behind some of our partners in Europe. Look at France, look at Germany, the Netherlands, Belgium, Denmark, over the last few years, they have been investing massively in schemes to bring geothermal heat to their agricultural industry, to their large heat users, hospitals, universities, and so on and so forth. We are not making a step into the unknown from looking at it from an industry-wide perspective. The UK just has some way to go to catch up. We are starting to see some momentum in that sense. Certainly, if I go back to when I first presented here 4 years ago, when it was just a concept, looking at those European partners. Now we're in a world where we've got projects underway. We've talked about Salisbury, Wythenshawe, Southampton, and so forth, and a large number of some PSDS funded and other projects which are being commercially funded, driving geothermal forward and bringing the benefits that those partnership schemes that I was describing can offer. I'm conscious of the warning I got from on high that the clock is about to tick, so I'm going to finish there. If people have got any questions, please feel free to ask now. Equally, myself and my colleague Simon, our contact details are on there. So if you're too shy or the question comes to you later.